Okay, so now we're going to be looking at Chapter 8, Topic 2. This is the 68, 95, 99.7 rule. That's called the empirical rule, okay, for normal distributions. This is something you guys talked about in Algebra 2, all right? So in any distribution that is roughly symmetric, unimodal, and bell-shaped, so essentially looking like these pictures here, the percentage of values within 1, 2, and 3 standard deviations of the mean is fairly predictable. Distributions that have this shape are called approximately normal. And the standard normal distribution is the normal distribution with a mean of 0 and a standard deviation of 1. We'll talk more about that in another section. But if a distribution is exactly normal, we can use this empirical rule to kind of estimate the percentage of values that are 1, 2, and 3 standard deviations from our mean. It turns out that 68% of data is within 1 standard deviation of the mean. You can see that here. Do you guys see that there's this little picture down here? Here's our mean. And then if we went 1 standard deviation to the left and 1 to the right, that encompasses about 68% of our data. So let's say that we moved to 2 standard deviations of the mean. That means that about 95% of data is within 2 standard deviations of the mean. And if we moved to 3 standard deviations from the mean, that's going to be about 99.7% of the data. And I think the most helpful of the curves, so this kind of demonstrates the 68 is 1 away, 95% would be 2 away, 99.7 would be 3 away. But this curve seems to be the one that is most helpful to everybody. Did you guys see these numbers in Algebra 2? Do you guys remember seeing those? Okay. So, and so these numbers should be memorized. So where does the 34% come from? Wasn't this 68% 1 standard deviation away? And what happens if you cut 68 in half? You get 34. So did you guys see that's where the 34s come from? Okay. So then what about these 13.5s? Where do those 13.5s come from? Well, it said that 2 standard deviations was 95 away, or 95% of the data. But haven't we already talked about 68% of the data? So that leaves us 27% left. But if we split the 27% in half, that's where the 13.5 comes from. If we continue that trend and say, all right, well, let's look at 99.7% of the data. If we took 99.7% of the data and we subtracted 95%, that gives us 4.7% that's left. And if we divide that by 2, that's where the 2.35 comes from. And then the whole graph represents 100%. So if I take 100% minus the 99.7% that we've already dealt with, that leaves us with 0.3%. And that 0.3% divided by 2 is the 0.15. But every time we do a curve, we're going to practice these percentages. But that's where they come from. Again, these guidelines only work for distributions that are approximately normal. So if we had something that was skewed left or skewed right, that would not work. Okay. So here's how these problems end up working out. So this says, during the 176 games, Indianapolis Colts quarterback Peyton Manning played in the NFL from 1998 to 2008. He averaged 259 passing yards per game with a standard deviation of 74 yards. His distribution of passing yards is approximately normal. That's good because that means that we can use the empirical rule for this. So it says, given the data above, draw a normal curve associated with Manning's mean and standard deviation. So what we're going to do is we're going to draw some sort of curve. Mine is really not cute at all, okay? But you're going to try to draw a curve that is unimodal, symmetric, bell-shaped. So you're going to draw a curve something like this, okay? We're going to put one line in the middle, and that line in the middle is going to represent our mean, okay? What did this say our mean was? 259. So we'll label this as 259. Okay. Now the empirical rule deals with things that are up to 3 standard deviations away. So to the right, you're going to go 1, 2, 3 other lines to the right. They should try to be equally spaced. And then 1, 2, 3 lines to the left. No more than 3. And then I would fill in the percentages. The percentages go in the middle here. 34%, 13.5%, 2.35%, and 0.15%. And if you memorize half of it, then you can just copy them over to the other half. So those percentages are something that you should draw on your graphs in your homework to help you memorize what those are. So the inside will always look the same when we use the empirical rule. But these values on the bottom are going to change. We labeled this middle part as 259 because that was our mean. It told us that the standard deviation was 74 yards. That means that I need to go 74 more yards to the right before I get that next boundary. So what we'll do is we'll add 74 yards to 259, and we get 333. What do you think we'll do to get the next value? Same thing, add another 74 yards. So adding another 74 yards gives us 407. We add another 74 yards to get 481. We do not label the very end of the graph because this kind of lets us go off and to have like very exceptional performances. So what do you think we would do to go to the left? Subtract instead. Good. So we'll take 259 minus 74 to get 185. Subtract another 74 to get 111. Subtract another 74 to get 37. And I'll label these as yards. Okay. But that's what a nice normal curve has. Notice that it has two things. It has percentages and it has boundaries. Okay, those boundary values. And if you set it up really nicely, it ends up being a piece of cake to figure these problems out. Letter B says, between which two values would you expect to find the middle 68% of Manning's performances? Well, wouldn't the middle 68% be with the 34s on each side? And the boundaries there are here, 185, and here, 333. So we would say, okay, between 185 yards and 333 yards. Then it asks, in what percentage of his performances would you expect that he threw for over 333 yards? Well, notice 333 yards is one of the boundaries. Over 333 yards would be which side? The left or the right? To the right. And can't we just add all of these different pieces up? So then you can add 13.5 plus 2.35 plus 0.15, and we get about 16%. Letter D then says, between which two values would you expect to find the middle 99.7% of the performances? Well, 99.7% is familiar. That's 3 standard deviations away. So we can go to our mean, and we can go 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left, and then we see those boundaries would be 37 yards and 481 yards. Isn't this the kind of stuff you guys did in Algebra 2 with us? From what I understand. Okay, pretty good? Okay. Any questions on that process? Okay. So let's skip this number 2 right here. This is fine. This is just a your turn. I'll have the worked out solutions online. We'll do it in a sec. But I do want to do this important note down here. A performance is exceptional if it is more than 2 standard deviations away from the mean. Okay? So anything is considered exceptional if it's more than 2 standard deviations away from the mean. It follows with what we've been talking about, because didn't we say that anything isn't 5% a cutoff for an exceptional performance that we've been dealing with so far this whole semester? So, and you think about it, 2 standard deviations away is 95% of the data, right? So then what's left? The 5%. So that's where that 2 standard deviations away. Like a normal performance would be within 2 standard deviations. So if you get a homework question where it asks you what is an exceptional, or is this an exceptional performance, then you could answer that question based on if it's more than 2 standard deviations away from the mean. Okay?